I changed a couple of the problems, guys. Can you guys let me know if I forgot to update it on yours? Does yours say that? Okay, I want to make sure. All right, it says use each differential equation to create a slope field. So it says dy dx is equal to negative x plus 1. There's not one way to do this problem, but I find it easier, at least myself. I like to make a little table to figure out what's happening. So what's nice about this equation is sometimes there's going to be x's and y's. Notice that there's just x's. Okay, so what I'm going to do is I'm going to make a table where I have x and then dy dx. And remember, dy dx really means slope, right? So look at your graph. You only have to pick the numbers you guys see on the graph. So on the x-axis, the only numbers I have are -2, -1, 0, 1, and 2. And all I need to do is to find the slope, plug these numbers into the equation. Okay, so if I plug in -2, what would that become? 3. -1, 2, 0, 1. And then sometimes it's nice, you kind of notice a pattern. What's happening? It's going down by 1. So it'd be 0, -1. Okay? So what that means is, now here comes the fun part. Now we get to sketch all those little hash marks. So technically, do you guys see how we have 5? 5. What's 5 times 5? I have to graph 25 hash marks. But what's nice about this is I'm only graphing the x values. So x is -2 right here, right? So at -2, -2, -2, -1, -2, 0, all the x values, the slope's going to be the same. Okay? So this is a positive slope. 3, that means I would go up 3 over 1. So that's kind of steep, right? So to draw a slope like that, it's going to look something like that. And then does it make sense? I can just copy paste that all the way down. So if you have an iPad, you literally can just copy paste the hash mark 5 times and just put them on those points. If you guys don't, it's okay because it's pretty quick, right? Just doot, doot, doot. So it should look like this. Doot, 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 doot. That's it. And then do the same thing for this. So 2, a slope of 2 is a little less steep. So maybe something like that. A slope of 1, so at 0, all these points right here, a slope of 1 is just like a perfectly diagonal line, so something like that. What does a slope of 0 look like? All lines are straight. Horizontal line. So something like this. Doot, 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 doot. And then at 2, the slope's -1, so it's a diagonal line, but going this way. Looks something like that. Hey, buddy. All right. Now here comes the cool part. We're not going to actually do the problem, but I want you guys to understand what this means. If I want to figure out what the y equation of this was, so that way I can kind of understand the slope field. Did you guys see how the slopes, as I'm going this way, how they're starting to get like less steep and it's starting to kind of curve? You guys see that? So if I integrate this side, this is going to be y. What would be the antiderivative of something x? It'd be like x squared, right? What type of function is x squared? Parabola. And do you guys see how it's negative? So which way is it going to open? Down. So do you guys see how like I could sketch a parabola through the slope field? Does that make sense? So this represents a quadratic if I actually figured out what the function was. Does that make sense? That's what this represents. Okay? All right, let's do another one. So this one's a little bit more annoying because it's y and x. I'm going to change a setting on my iPad real quick. Give me a second. Okay. All right. So this is how I'm going to do the table. You guys can do it however you guys want, as long as it makes sense to you guys. I don't care. But this is how I'm going to do it. I'm going to make a column for x. So if I look at my graph, where does the x-axis begin? -1, so I'm going to make a row for -1, 0, 1, and 2. But then, where does the y-axis start? -2, right? So do you guys see how there's more values for y than for x? So we can't make a traditional XY table that we're used to. So this is how I'm going to do it, and I'll explain to you guys what I mean. I'm going to put a y right there, and then I'm going to go -2, -1, 0, 1, and 2. And then I'm going to make my table like this. This looks kind of weird, right? But hopefully this makes sense. Right here, guys, this means when x is -1 and when y is -2, what's the slope? That's what this is going to represent. Okay? So all I'm going to do is I'm going to plug in y and x into every box, and you guys will see patterns. And once you guys start to see the pattern, it'll help you guys fill it out faster. Okay? So if I plug in y, what's -2 minus -1? -1. What's -1 minus -1? 0. What would be 0 minus -1? 1. So let's pause. Did you guys notice a pattern? What's happening? This is going up or down? Up by 1. So what would this be? 2. And this would be 3. I'm not going to be checking for work off to the side. So please don't do, what is that, like 20? Please don't do 20 calculations like off to the side. Okay? All right, if I plug in -2 minus 0, this is -2. -1 minus 0, this is -1. These are going up by 1. So this is going to be 0, 1, and 2. So then also going down, do you guys start to see a pattern? So what's happening here? It's going smaller by 1. So this would be -3, -4. This would be, it's going down, so -2, -3. This is going down, so -1, -2. This is 0, -1, 1, 0. Oops, sorry. Okay, so now all you have to do is sketch those little slopes. So starting at y is equal to -2. So that would be all of these values right there. Wait. Oh, I have 4. So -2, -1, -2 is -1. So that would look something like that. -1. Actually, let's go this way. This makes more sense to me. -1, -1, I have a slope of 0. -1, comma 0, I have a slope of 1. -1, comma 1, I have a slope of 2, so it's a little bit steeper. And then -1, comma 3, I have a even steeper slope, so something like that. Okay, is everybody okay? Does this make sense? All right. For x is 0, it's going to be -2, so a little bit steeper. And then -1, 0, 1, and then 2. At 1 comma -2 is -3, so it's kind of steep. -2, so a little less steep. -1, 0, and then 1. At 2 comma -2, it's -4, so it's really steep. And then -3, so it's still pretty steep. -2, -1, and then 0. So sometimes it's hard to tell what function this would be. Like here, we don't have the tools to actually integrate this yet. Because remember what I told you guys, technically you're multiplying both sides by dx. And if I do that, I'll have y dx minus x dx. If I move the y over here, then I have an issue. I still have dx over here. So we can't actually integrate this the way that we know how to do yet. That would be like a college level problem. So like whatever function this is, we actually don't have a way to figure that out right now. But as you guys will see in the other problems, we can still try to figure out what this is using different tools. All right. So the rest of this lesson, I'm pretty much giving you guys like sample problems you guys could see on an AP test. Okay. The figure below shows the slope for the differential equation dy dx is equal to 1 minus xy. Let f be the function that satisfies the given differential equation. Write an equation for the tangent line to the curve y is equal to f of x through the point -1, -2. Who wants extra credit? What's this equation for the slope of the tangent line? Whoever knows it, raise your hand. Slope of the tangent line. All right, good thing the AP test is not today. Because you guys remember, we did a lot of problems like that in the fall, right? So not next week. Next week is our last week of new stuff, guys. Starting the week of the 14th is AP. We're going to start reviewing. Okay, so y minus y1 is equal to m times x minus x1. Now that you guys see that, we remember that, right? Hopefully. Okay. So this is my point, right? So if you guys remember, this is your x1, y1. It is, but the equation of the point slope form will give us the equation of the tangent line. But yes, we put it into point slope form. They just have different names. Math is confusing. Oh, sorry. What does this mean? Slope. Don't I know what this is? So to figure out the slope, all I have to do is plug in the numbers. Guys, this was like an FRQ question a couple years ago, and the guy that I get these problems from, he said that a lot of kids got this wrong. But that's pretty easy, right? All I have to do is plug in x and y, and boom, I have my slope. Okay, so dy dx is equal to 1 minus x is -1, y is -2. So if I simplify this, this is just 2. So then it would be -1. So this is my slope. So my equation is going to be y minus -2, so y plus 2 is equal to -1, or just negative, x plus 1. If you guys do go home and watch the Algebra Bros video, they do this weird graph right here, but I feel like if I showed you guys the same thing, you guys would get confused. So I'm going to skip that part. Okay. All right, so how do you, I told you guys there's going to be matching and multiple choice, so let's practice doing some of those questions. Below is a slope field for which of the following differential equations? So this could be a sample question on the AP exam. Okay. What I would do first, and hopefully you guys understand why this makes sense, I would look for anywhere the slope is undefined first. So like if you look at D, do you guys see how there's a y on the bottom? Are we allowed to divide by 0? No. So I would make a note to myself, if y equals 0, m is undefined. Okay? So if I look at my graph, this one, it's actually hard to tell. On a slope field, doesn't undefined slope mean this? On the slope field, usually what I've noticed is that the slope field, there won't be any like hash marks. So if it's undefined, it'll be like blank. So do you guys see how like on the x-axis, there's technically no tick marks? So this actually could be the correct answer then. So I'm gonna put like a little star next to this one because that could be the answer, okay? So what you could also do is you guys could just pick a point where you for sure know the slope. So what I want you guys to notice is this is a point 1, -1, right? Can you guys see that on the graph? What's the slope right there? 0. So what you could do is plug in 1, -1 into these equations. And if it's not 0, it can't be that equation. Does that make sense? So does this equation even have a y? No. So x is 1, right? What's 1 plus 1? Is that 0? So it can't be A. If I plug in 1 there, what's 1 squared? Can't be B. What's 1 plus -1? 0. So I'm going to put a star next to this one because it could be C. X is 1, y is -1. What's 1 divided by -1? -1. That's not 0, so now we know for sure it's not D. Okay? This equation only has a y. Can I take the natural log of -1? No, because the argument has to be positive, so it can't be E. So the answer has to be C. Sometimes, and we did something like this at my AP training, and I have it in my drive, and I might, if we have time, I might do it with you guys. They gave us all these like little flashcards, and we had to like match and sort them. Some of them were hard. And you had to, how many points did we really have to pick to figure it out? We just picked 1 point. Sometimes you have to pick like 3 or 4 points to kind of narrow it down what they would be. And all of us pretty much ran out of time because the guy was like, oh, that's it. Sorry. We're going to move on now. I'm like, no, I want to figure it out. But does that make sense? Because like I could pick this point, but is that slope 2/3? I have no idea what this is, but does that make sense that that slope for sure is 0? That's why I picked that point. All right, so let's look at B. The slope field for a certain differential equation is shown to the right. Which of the following could be a solution to the equation with the initial condition y of 0 is equal to 0? Okay. So what you would do is, knowing this information before I even look at the graph, what I could do is plug in x is 0, and I better get 0 as my answer, okay? So if I plug in a 0 right here, 0 over 0 minus 4, is that 0? Yes. What's the tangent of 0? 0. 2 plus x, that's 2. 0 divided by 2, that is 0. If I plug in a 0 there, this would be e to the 0 plus 2, which is e squared. Is that 0? So it can't be c. If I plug in 0 there, 0 squared is 0, divided by 2, that is 0. So that helped me get rid of c, okay? So if you're on an AP test, if you even guess, you have a better chance of getting it right now that you know for sure it's not that, okay? What do you guys notice about the graph? Does something jump out you guys about the graph? It's undefined where? At -2, okay? So that means that on the graph we have an asymptote, okay? So check it out. Can I pick -2 in this function? No, because then the bottom would be undefined. So it could be D. It could be B. Here, what should I technically do to the bottom? Factor. So if I factor this, I don't know why I put my pencil in my pocket. That was weird. If I factor this, this would be x plus 2, x minus 2, which means we have 2 asymptotes. But looking at the graph, how many does it look like we have? 1. So if this was the answer, I should also have an asymptote at +2. So it can't be A. So that leaves me with B and D as my answer choices, okay? Now, the easiest way to explain this is, unfortunately, guys, if you guys know anything about your parent functions, this one's actually really easy. Because what do we know about the tangent graph? Do you guys remember from pre-cal or Math 3 Honors? It has how many? A lot. How many do you guys see here? 1. So it's D. Hooray. Okay. All right, cool, we're almost done. Calculate or consider the differential equation dy dx is equal to xy over 2 and its slope field shown below. Calculate dy dx at the point 1, 1 and verify that the results agree with the figure. So I'm going to plug in 1, 1 into my equation. So if you guys want to be fancy, you could say dy dx at the point 1, 1 equals. So if I plug in 1, 1, I'm going to get 1 times 1 divided by 2, which is 1/2. So if I go to my graph, does it look like at 1, 1, guys, the slope could be 1/2? Yeah, it looks like it could be 1/2. So I'm going to say, sure. It agrees. Cool. Okay. Now, this question, you guys technically haven't learned this yet because I skipped it because of time, but we're going to cover it right now because it's actually not that hard. It says, let f be a function that satisfies the given differential equation. Write the equation for the tangent line to the curve through the point 1, comma, negative 1. So to write the equation of the tangent line, guys, we need a point, which we have, and we also need the slope. And guess what? We have the slope, okay? So the tangent line remember is y minus y1 is equal to m times x minus x1. So what's y1? 1. What's our slope? Okay, is everyone cool with where that came from? Now, what we skipped is something called linear approximation. What this means is it says use your tangent line to estimate the value of f of 1.2. Do you guys agree that this is x is 1, right? Do you guys agree that 1.2 is pretty close to 1? What this means is if I know my tangent line of the equation of this point and this value is really close to that point, all I have to do is to estimate it, take my tangent line, plug that in for x, and get a number. That's what that means, okay? So y minus 1 is equal to 1/2 times 1.2 minus 1. What's half of 0.2? 0.1, right? And then to get y by itself, add 1. So y equals 1.1. That wasn't that hard, right? There's a whole lesson in my textbook that I used in the first semester that goes over that. But I figured that I could just teach you guys pretty fast, okay? Okay, questions on this problem? Oh, sorry. All right, here's another AP exam question. Consider the equation. Go ahead. Yeah. Oh, you need more? I don't know where I put that. I have paper towels. If you need more, bro, paper towel. You're good. You're good. Consider the differential equation dy dx is x plus 1 over y, and its slope field shown. Describe all points in the xy plane for which dy dx is equal to negative 1. So from the earlier examples, guys, didn't we practice graphing a slope of negative 1 on the slope field? Okay. So what I want to ask you guys is, can you guys notice anywhere on the graph where the slope looks like it's negative 1? Do you guys see it? I see a couple nods. What type of function does that look like? It looks linear, right? So if you guys don't see it, I'm talking about this right there. All those slopes look like it's negative 1, right? And it's forming a line. So check this out. This problem's actually pretty cool. I want to find all the values that give me a slope of negative 1. So I'm going to set dy dx to equal negative 1 and solve for y. So I'm going to multiply both sides by y. And then divide everything by -1. So y is equal to -x minus 1. Now this should make sense because what's the slope of this line? -1. And then we say that this looks linear. That equation is -x minus 1. That's actually pretty cool. So this describe all points. So we're going to say all points that lie on the line y equals -x minus 1. All right, last problem. Okay. Oh man, I didn't change my notes. Your guys' looks different, right? Does it say A and B? Okay. So which one is this one 0, 1? And this one's 0, 0? Okay. All right. So this is honestly kind of difficult at first to visualize, but what you're doing is you're going to plot the point on the slope field. So 0, 1 would be right there. And what you're paying attention to is you're looking at the hash marks and how they're behaving. So if I were to draw a function that goes through this point, it also needs to kind of follow the behavior of the slopes. Okay? So I'm going to try to draw a function that fits through the slope field. Okay? And the rule you have to follow is the curve that you draw, it has to be parallel to the slope field, to the little hash marks. So what I want you guys to notice is, do you guys see how, like, if I were to draw a curve, think about it, the way that the algebra guy describes it is he talks about how like a leaf in the river and how it, like a current would kind of push the leaf or whatever as it like floats away. So do you guys see if I go this way, how the slopes are kind of curving like that? Do you guys see that? So if I were to draw the curve going this way, it would look something like that. And the rule you have to follow is you have to exit the slope field and have an arrow. Okay, so it has to keep going out of the slope field like that. Then if I go this way, so do you guys see how this line right here is like that? So I need to draw a curve so it's parallel to it like that. Then it gets flat, and then it looks like that. And then it goes like this and out that way. Now, I'm not going to be like super particular about at least the beginning. Like if you accidentally draw it below that, but does it make sense that this curve fits between all those hash marks? Does that make sense? Okay. And from my buddy that I go to when I have questions about teaching this class, he tells me that this has been a free FRQ before too. It's like, here's a graph, sketch the solution to that point. So this is all you do. And it's either 1 point, 2 points, whatever. Okay. Now we're going to do the same thing for this point, 0, 0. So I want you guys to look like before that point and after that point and see if you guys notice something. What does it kind of look like? Looks like a sine graph to me. So can you guys visualize that? Like, it looks like it goes, wait, I didn't mean to do that. It kind of looks like that. Can you guys see that? So we're gonna try to sketch something that looks like that. So it comes down, gets flat, starts to rise and exits. Here, it's flat, comes down, and then exits like that. Okay.